Hi everyone. In today's lesson, we're going to talk about how to evaluate functions from a graph and how to evaluate functions algebraically. So first, I want to go over this specific graph. This is a graph called a piecewise function. It's a function made up of three different pieces, more specifically, three different lines. So I want to use this graph to determine, is the graph a function? So if you remember from yesterday's video, a function is something that passes the vertical line test. So if I were to draw lines here, here, and here, they only hit in one spot. So it passes there, but we have to check all the pieces. So if we look over here, it would definitely pass there. It would definitely pass all these places, right? It only hits once. But the place that we have to be very specific about is this spot right here. So if I'm drawing a vertical line here, notice how it appears that it's hitting in two spots, right? But one of them happens to be an open circle. So technically, it doesn't actually go through there. So it really only hits in this one spot. So it actually does pass the vertical line test there. And then same thing over here. It looks like it hits twice, but really this open circle down here, that means that it's actually not equal to at that point, but that it's equal at a closed circle, right? So the closed circle is equal to. So it really only hits in this one specific spot. So really, this graph is definitely, yes, a function. Okay, so let's talk about now the domain and the range. So domain is how wide the graph is. So we have here, we have an endpoint. There isn't an arrow saying it's going on forever. So this is the end of the x value if we go all the way down to here. So let's count. 1, 2, 3, 4, 5, 6, 7. So actually it's -7. And it's a hard bracket because it's a closed circle, which means equal to, so that gets a hard bracket. And let's go all the way to the other side. 1, 2, 3, 4, 5, 6, 7, right? That's as far right that the graph goes. So the 7 would go here. And the range is how tall the graph is. So the lowest point goes first, then the highest. So let's see, the lowest point is about here, right? So 1, 2, 3, 4. So -4 is the lowest y value. But you actually have to use a parenthesis. And the reason why you have to use a parenthesis is because at y equals -4, there's an open circle. Open circles get open parentheses, and closed circles gets brackets. So now how tall does it go? It goes 1, 2, 3, 4, 5, and 6, right? All the way up here, 6 is the highest, but it's at a closed circle, so it would be a bracket. So it's 6 and then bracket, okay? And then we want to evaluate the function. So what is f of 0? So what is the y value when x is 0? So when x is 0, the y value, the graph is at -1. F of 4 means what is the y value when x is 4? So 1, 2, 3, 4. So at x equals 4, there's two y values. It's this one or this one. So just like before, we're only going to look at the closed circles. So f of 4, 1, 2, 3, 4, is -1. -3, f of -3. So 1, 2, 3, the x value. So again, we have two options, but we always go to the closed circle. So that's a y value of 2. And last but not least is f of -6. So here's -5, and here's -6. So we look up to the graph. 1, 2, 3, 4, 5. Perfect. Okay, oh, there's one more question. State all values of x for which f of x is -1. So in other words, they want to find all x values for when y is equal to -1, right? Because f of x is the same thing as saying y equals. So here's the y value of -1. So they want all the x values that this occurs from. So 1, 2, 3, this is -3. 1, 2, 3, 4. So it goes from -3 to 4, but there is an open circle and then a closed circle. So open circles get parentheses, closed circles gets brackets. So that would actually be your final answer. Okay, so now let's move on to evaluating functions algebraically. So the directions say evaluate the function below for each of the given values. So these are all different problems. If you want to make it a little bit more clear, you can write this as part A, part B, part C, part D, and then part E. So same function. I'm given f of x, and the first part I want you to find f of 2. So you should remember from algebra that everywhere you see an x, you're going to put a 2. So we have 4, -4, 2 for x squared, plus 3, and then 2 for x. So what we would do is type this into the calculator and get an answer. We'll come back to the answers later, but that's the process. So if I want to find part B, f of 5a, same concept. Everywhere I see an x, I'm going to put a 5a. So we have -4 x squared plus 3x. So everywhere I have an x, I'm going to put 5a. So 5a and 5a. And again, we can simplify this a little bit further for sure, but we'll do that a little bit later. So the concept that I want you to get here is that no matter what I put in the parentheses, I could put blah in the parentheses. Wherever I see an x, I'm putting blah. So same concept. We have -4, x is blah, squared, plus 3 times blah. So now, if part D, I want to find f of x minus 2. Everywhere I see an x, I'm putting an x minus 2. So we have -4, x minus 2 squared, plus 3 times x minus 2. Notice for every single one of these problems, no matter what happened inside, I'm still having the same exact setup. 4 times something squared plus 3 times something. 4 times something squared plus 3 times something. Now, I don't want you to confuse f of x minus 2 with f of x then minus 2. So what this one would actually look like would be if this is your f of x, right? This guy right here. You would do f of x, then minus 2. So if your f of x is -4x squared plus 3x, then you would subtract 2. Notice the very difference between that and this, right? Okay, so same kind of concept over here. If I want to find f of x plus h, everywhere I see an x, I want to put an x plus h. So I have -4 x plus h squared plus 3 times x plus h. So same thing. Now I don't want you to confuse that with f of x and then plus h. So again, if this is your f of x, we're simply taking f of x, which is the original, then adding h. So my f of x is 4x squared plus 3, then plus h. So there's a very big difference between f of x plus h in the parentheses and f of x then plus h. F of x is the original function. I know it's a lot, but what I'd like you to do now is to try to simplify some of these. So go ahead and pause the video, type A into the calculator, and then hit resume when you're ready for the answer. Okay, so you should have gotten -10. That should be your final answer for part A. Now, for part B, I'm going to talk you through it before we can simplify it. So we want to consider this as PEMDAS. So what I do, if I have PEMDAS, I know it's been a while, so I'll write it over here, parentheses, exponents, multiplication, division, addition, and subtraction. I forgot my D, right? PEMDAS. So what we would do first is anything inside the parentheses, like if I was adding or what have you, I can't do that. Then I do exponents. So I would do 5a, that whole thing squared. Then I multiply by -4. So you wouldn't multiply these first, you'd actually raise first. So when I take 5a and square it, that's really the same thing as saying 5a times 5a. Or you could just distribute the power. So you would get -4 times 25a squared. And I got the 25a squared because I did 5 squared, which was 25, and then a squared, which is a squared. So then I multiply the 4, and then I can add this together. So we can add this to 3 times 5a, and now we can multiply, right? We did parentheses, exponents. Now we're going to multiply, and then we're going to add. So I'm going to multiply these two together, and I get -100a squared plus 15a. So this is the answer for 1, and this is the answer for 2. Now, obviously, number 3, or part C, we can't simplify. It's just blah. That one was there to show you the process. I'd actually like to go over part D, but I think there's not enough space here. So I'm actually going to add a page and go through the work there. Okay, so the way that we're going to simplify this expression is through using PEMDAS. So PEMDAS. So P stands for parentheses. So if there was an actual subtraction that we could do, like if this was a number, we would actually do that, but we can't. So then we move on to E. E says exponents, right? So we're going to do this exponent first. So we have x minus 2 squared. That's the same thing as saying x minus 2 times x minus 2. So we're going to do that first. Then we're going to multiply it by this -4 on the outside, and then we can add the 3 times the x minus 2. Now I use these brackets because I just didn't want to put bigger parentheses, but they're the same thing as parentheses, so don't stress. So we're going to do this first. So we're going to FOIL this out, or double distribute. So we have x times x, which is x squared. X times -2 is -2x. -2 times x again. And -2 times -2 is a +4. Here are my like terms. So x squared minus 4x plus 4. And then we're going to multiply this by this -4 on the outside, and then we're going to add the 3 times the x minus 2. So now we're up to multiplication, right? So we can multiply, aka distributing, right? So we can distribute the 4 and the 3. So we get -4x squared plus 16x minus 16 plus 3x and then minus 6. So if we combine our like terms, we have -4x squared. 16 plus 3 is 19x. And then -16 minus 6 is -22. So that would be our final simplified answer. Okay, how about the last part? So part E, I'd actually like you guys to try to double distribute and simplify, right? Same kind of concept as we did before, except now it's variables x and h. So give it a try and then hit resume when you're ready for the answer. So again, we're going to take this x plus h and we're going to square it or multiply it by itself. And then we're going to multiply the -4 on the outside when we're done, and then add the 3 times x plus h. So when we multiply or double distribute, we do x times x, which is x squared, x times h, which is simply xh, h times x one more time is hx or xh, same thing, and h times h is h squared. So now these are my like terms. So if I have one xh and I have another xh, how many xh's do I have? I have two xh's. Then I add the h squared. So since I have no other like terms, I'm going to go ahead and bring down my negative 4. And then I'm going to bring down my plus 3x plus h. So same thing like last, we're going to distribute the 3. So we've got negative 4 times x squared minus 8xh minus 4h squared plus 3x plus 3h. So let's see if there are any like terms. I have an x squared. I don't see any of those. An xh. I don't see any of those. H squared, no. X, no. H, no. Okay, looks like I can't simplify this any further. This is my final answer. And don't stress if you're having trouble with this. We will absolutely go over it in class. All right, have a good night, everyone.